Welcome back, friends. Today we are going to talk about colligative properties, and today we are going to continue with the boiling point elevation as one among the colligative properties. So in the previous session we discussed about the lowering of vapor pressure, and we had solved the example session. So we solved a lot regarding the lowering of vapor pressure, and in today's session we are going to continue with the discussion about lowering of boiling point. So don't worry, the notes for this session, they are free and you will get them. So one thing you need to understand is that if you viewed the lowering of vapor pressure session, we gave an instruction, or we gave information how the increase or addition of the non-volatile solute in a solvent leads to the lowering of vapor pressure. Now in the boiling point, we are going to continue that concept, because the same concept is applicable in the boiling point. Now about the boiling point elevation, we are firstly defining about the boiling point itself. Boiling point is the temperature at which the vapor pressure of the liquid is equal to the atmospheric pressure. Is the temperature at which boiling point is the temperature at which vapor pressure of the liquid, vapor pressure is equal to atmospheric pressure. Now, remember, atmospheric pressure is 1 atm. So, in case 1, if we don't have a solvent, maybe if we want 100 degrees Celsius for a liquid, 100 degrees Celsius. So if we heat a liquid to 100 degrees Celsius, it reaches 1 atm. And if we add a non-volatile solute in that liquid, that means non-volatile solute will increase the intermolecular forces of attraction between the molecules and will prevent the molecules to escape into the vapor phase, kama tupo discuss kwenye lowering of vapor pressure. Kwa hiyo kama non-volatile solute itakuwa ina prevent molecules ku escape kwenda kwenye vapor phase, maana nini kitatokea? Kwenye non-volatile solute kitakachotokea, maana temperature ya 100 degrees Celsius haitatufikisha kwenye 1 atm, itatufikisha kwenye pressure fulani ambayo it's lower. Let's say it is 0.8 atm. It is 0.8 atm. Why? It's because kumetokea lowering of vapor pressure. Tunapoongeza non-volatile solute inaongeza intermolecular force of attraction, and thus ina lead to the lowering of vapor pressure. Kwa kama lowering of vapor pressure ishatokea, manake ili tufikie 1 atm tutafanyaje? We need to increase temperature. We need to increase heat supply in order to reach 1 atm. So the heat which is increased here is what we call the elevation of boiling point. Kwa boiling point elevation inatokea kwa namna kama hii hapa. The phenomena is like this way. We have a boiling point of the liquid at which the pressure is equal to the atmospheric pressure. But when you add non-volatile solute, the non-volatile solute tend to decrease the vapor pressure of the liquid, and thus we need to apply more heat so that to cause the escape of the molecules into the vapor phase. And by causing the escape of the molecules into the vapor phase, then we will cause this pressure to increase to 1 atm, which is equal to atmospheric pressure. So, kama tusingeongeza temperature ikazidi ile normal, manake liquid yetu ingeshindwa kuboil. Hivi ndivyo ambavyo boiling point elevation inatokea. And the usual or the common phenomenon of all colligative properties, the boiling point elevation depends on the number of solute particles dissolved in the solution, and not on the chemical nature or on the size of the particles dissolved in the solution. So we are saying boiling point of a substance is the temperature to which vapor pressure of a substance is equal to the atmospheric pressure. So always the boiling point of a solution which contain non-volatile solute is greater than that of the pure solvent in the solution after introduction of the solute. So this is because the solution inakuwa na lower vapor pressure. The solution which has a low vapor pressure would need to be heated to high temperature in order for the vapor pressure to be equal to the external pressure, that is the atmospheric pressure. So the boiling point of the solvent in the solution change, but does not depend on the identity or nature of the particles, but depend only on the number of particles, as we discussed the general properties of all colligative properties. So the boiling point elevation, or the increase in the boiling point varies directly proportional to the molar concentration of the solute. Molar concentration of the solute. Now, if you remember, tulivyokuwa tunadiscuss kuhusu parameters ambazo zitapima property ya solution, tulidiscuss kitu kilikuwa kinaitwa molarity. And we said molarity is equal to number of moles of solute, divided by mass of solvent in kilogram. So the number of moles of solute divided by mass of solvent in kilogram. So tunachosema ni kwamba elevation of boiling point, that is change in temperature, is directly proportional to molarity M. That is to say, elevation of boiling point change in temperature is directly proportional to the number of moles of solute divided by mass of solvent in kilogram. Mass of solvent in kilogram. Kwa hiyo hivi ndivyo ambavyo variation ipo kati ya change in boiling point ya huyu hapa. Anategemea molarity. So change in temperature ni nini? Kama tunafahamu kwamba boiling point ya solution ambayo tunaweza kama ni T. Boiling point ya solution T itakuwa kubwa kuliko boiling point ya pure liquid. Tuite kama TB. So let T be the boiling point of the solution. Boiling point of the solution. Wakati TB iwe ni boiling point of pure liquid. Boiling point of pure. So the boiling point of solution T is greater than the boiling point of pure liquid, which is TB. So change in temperature will be equal to temperature ile kubwa ambayo ni boiling point of the solution minus TB, ambayo ni temperature of the pure liquid. So hiyo ndio itakuwa change in temperature. Boiling point of the solution minus boiling point of the pure liquid minus boiling point of the pure liquid. So kitu ambacho tunatakiwa kujua hapa ni kwamba change in temperature in a very direct proportion to the molarity of the solution. Na ujue tu change in temperature ni boiling point of the solution minus boiling point of the liquid. So tunayo vapor pressure boiling point curve. Vapor pressure boiling point curve. Kwenye hii curve tunakuwa tuna vapor pressure huko na tunakuwa tuna boiling point huko. Sasa kwa mfano tukawa tuna solution yetu, let's say ina pressure fulani pale, pressure P. This is the vapor pressure. Sasa tukataka kujua variation kati ya pressure na temperature ipoje. Variation kati ya pressure na temperature ipoje. If we consider the Charles law na zile graph zao, you can get this variation. Variation yake haiwi straight line, but it is in this version. This is the way temperature and pressure they vary. So here tutakuwa tuna pressure fulani na pia tutakuwa na temperature fulani. Tutakuwa na temperature fulani TB. Remember, this is the pressure of the pure solvent. TB will be the temperature of the pure solvent. I mean, boiling point of the pure solvent. And P is the vapor pressure of the pure solvent. So kutakuwa na vapor pressure, huku tunakuwa na boiling point. Kwa hiyo hii hapa itakuwa ni pressure of the pure solvent, temperature of the pure solvent. Now, what will happen kama tukiadi solid? Tukiadi solid hapa, maana yake ni kwamba temperature itaongezeka. So maana yake tukiadi solid ili tuweze kufikia pressure ile pale. Pressure ile ya mwanzoni ambayo ni pressure hii hapa, kama ni sawa sawa na atmospheric pressure, ndio liquid itaboil. Ili tuweze kufikia ile pale pressure ile, lazima temperature iongezeke. So tukiadi solid, temperature will increase. However, the version of variation will be the same. So you see, ili tuweze kufikia pressure ile pale, kama tumeadi solid, we must increase the temperature from this temperature TB twende kwenye temperature fulani T1, which is greater than temperature TB. So from TB to T1, hapa kutakuwa kuna interval ambayo tunaweza kuita kama ni change in T. Change in T. Kutoka hapa hadi hapo kutakuwa kuna change in T. Tumetoka TB tumeenda T1. Tulivyoongeza solid ili tuweze kufikia pressure ile pale, lazima tufanyeje? Tuongeze temperature. Lakini in case tukawa na temperature ile ya mwanzo TB, tulivyoongeza solid, unakuta pressure itakuwa ni nyingine. Tukiongeza solid. So tukiongeza solid, temperature itabakia ya mwanzo. Pressure hapa tuite ni pressure P1. Kwa hiyo temperature TB, unaelewa? Temperature TB kwenye tulivyoongeza solid, tunapata pressure ambayo ni new, which is lower. Hasa kama hii pressure ni lower, haiwezi kusababisha liquid boil. Maana tunatakiwa tuongeze temperature kiwango ambacho hii pressure itaongezeka hadi ifike hapa, ndio liquid iboil. Now in case ukaongeza solid nyingine huko, ukiwa unaongeza solid, hii graph inazidi kwenda hivi kuzidi kuongeza temperature. So on increasing solid, tutahitaji tuongeze tena temperature. We will reach somewhere there. So we'll have a graph. You see? Kwa unapozidi kuongeza solid, unazidi kuongeza temperature required to reach that pressure. Unapozidi kuongeza solid, unazidi kuongeza temperature required to reach this pressure. So unapozidi kuongeza solid, the thermodynamic force of attraction, they increase also. So kitakachokuwepo hapa tutakuwa na temperature fulani. Let's call this temperature as temperature T2. Let's call this temperature T2. And in this case, kama tukiwa tuna temperature ile ya mwanzo, that means tutakuwa tuna pressure fulani. Kama tukiwa tuna temperature ile ya mwanzo, tutakuwa tuna pressure fulani P2. Kwa unaweza kuona what happens kama tukibakia na temperature ile ya mwanzo. Yaani kwa temperature ile ya mwanzo tulivyoongeza solid, tunakuta pressure ndio imepungua zaidi. Kwa as we are increasing solid, the vapor pressure decrease. Unaona tunaongeza solid, temperature ile vapor pressure hapo. Solid ilivyokuwa pale katikati, temperature ile vapor pressure hapo. Solid ilivyokuwa hamna kabisa, temperature ile pressure ile pale. So as we are increasing solid, vapor pressure decrease, lowering of vapor pressure. And as we are increasing solid, the temperature required to boil that liquid in order to reach this pressure also increase. So let's say here we have point E, we have point D. Then from there we have point A, we have point B, and then you have point C. Let's say hizi ni point tu ambazo ni za assumption. So variation, the ratio of variation of pressure and temperature, they are proportional. The ratio of variation of pressure and temperature. The ratio of variation of pressure and temperature, they are proportional. That is to say, if we take AB divided by AC from this graph, AB divided by AC is equal to AD divided by AE. Yani manake AB ni change in temperature. Tulivyohadi solid. AB ni change in temperature tulivyohadi solid. AC ni change in temperature ya pili tulivyoongeza solid. AC change in temperature ya pili tulivyoongeza solid. This is equal to AD, which is change in pressure tulivyoongeza solid mara ya kwanza. AD change in pressure. So AD divided by AE, which is change in pressure tulivyoongeza solid wa pili. AE, the total change in pressure. AB, AC. AD change in pressure. AE total change in pressure. AB change in temperature. AC total change in temperature tulivyoongeza solid wa pili. So AE, that is to say AB is T1 minus TB, because T1 ni kubwa kuliko TB. So AB is T1 minus TB divided by, from there, AC, which is T2 minus TB, is equal to ADP, which is greater minus P1. So it is P minus P1 divided by AE, it is P minus P2. P minus P2. So this is the ratio which you can conclude. Ndio ratio ambayo tunataka conclude kutoka kwenye graph. The ratio which shows the relationship between the boiling points and the pressure above zinakuwa zina vary. Hiyo ndio ratio ambayo tunaweza kuitoa kwenye graph. So one thing you need to understand ni kuhusu graph na jinsi ambavyo hizo boiling points zinakuwa zina vary as you increase in solidity. Boiling point ambazo zinakuwa zina vary as you increase in solidity. In the next session, we discuss about the molar elevation constant, and we'll be having the calculations regarding the boiling point elevation. So thank you everybody, and later wish you nice studies. Thank you.